Hello, welcome back to another AP3 video. In today's video, we're going over AP Environmental Science, topic 6.3, fuel types and uses. So the first thing we're going to talk about is what are some types of fuels and what are they used for. So you have wood and charcoal, and they're primarily used in developing countries as they're easily accessible to. And wood is one of the oldest fuels used for energy. Now, charcoal is made up from wood, but needs some processing. Basically, charcoal burns hotter than wood, which is the benefit of it. And to get it, we need to superheat wood without oxygen, getting rid of the impurities, giving it its dark color, and combusts easier due to it not having H2O vapor. The cons of it is that removal of trees can lead to soil erosion, and soil erosion or soil degradation leads to fuel security issues. Deforestation, which is just cutting all the trees in a particular location, could be a rainforest, could be a woods, but deforestation can decrease the amount of precipitation and CO2 sequestration. And now we're going to talk about peat. Now, peat is a primary decomposed material that can be burned for fuel. Now, developing countries can use peat as an energy source, and it's a precursor to coal. And we can find it depending on how big the topsoil is, seeing a dark, rich, organic material, and we'll pile it up, and if it's given heat, time, and pressure, it'll slowly turn into soil. But if we take little blocks out of it and bring it to the surface, allowing it to dry, they'll harden and turn into little bricks that can be burned for energy. And we can use it as an energy source. The problem with is that using these fuels indoors without using proper ventilation can cause indoor air pollution, causing health problems, which can cause respiratory illnesses, asthma, and trouble breathing. Okay, now we're going to talk about coal. Now, there's three types of coal that are used for fuel, and as heat and pressure increases and lasts longer, there's going to be a different type of coal. So we have peat, which is not a coal, and as pressure and heat increase and last longer, we have lignite and a bituminous and an anthracite. So with lignite, there's going to be low heat capacity because it's not under heat and pressure as long, the least valuable coal. It doesn't produce as much heat as to anthracite. It's going to have low sulfur. It's going to have high moisture. Now, bituminous, it's one in the middle. It has an in-between in the amount of heat used. It has the most sulfur and produces most sulfur in atmosphere, and it's most commonly used. Now, anthracite's kind of the best one because it has the best quality. So it's going to have the lowest sulfur, and it has a high heating capacity because it has the most carbon. Again, low sulfur, and it's going to be the most valuable coal because of that. And it has the longest amount of heat and most pressure, the least amount of impurities, but it's going to be the most expensive because it's high quality. Now we're going to go over, before, one thing that I left out. Sulfuric emissions mix with HO2 vapor and cause acid deposition. And that's really important as well. So what's the cleanest burning fossil fuel? Well, natural gas is the cleanest fossil fuel because it doesn't release as many harmful emissions as the other fossil fuels. Coal has a lot of sulfur compared to natural gas. It releases negligible amount of CO2, mercury, and particulates in comparison to coal and oil, and the amount of sulfur natural gas can make is negligible, and few impurities like sulfur is being released. And again, it's known as the cleanest fossil fuel, but it still produces carbon dioxide, which is really important. The impurities will have filtered out during the processing process. The good thing about natural gas, it's light, and it's mostly methane, and because it's light, we're able to transport it through pipes, but it can escape in the pipes. So, and that's an advantage because it's light, it can be transported a lot easier through pipes, but again, it can escape. Now we're going to talk about tar sands. So tar sands are a mixture of water, sand, some impurities, and some crude oil. Now, new source of energy or oil, but it's not ideal. But the easier way to get oil is in the ground in liquid form already, and just pump it up. But because fossil fuels are becoming less and less, and you get what you get basically, there's new methods being used getting the crude oil. Now, if we're pushing, we only use it if we're pushing extremes and need the oil, and we will use the method to get the oil from tar sands. Now, we need to remove the water and the sand and impurity and purify an area before we can get the oil drum. So before we get the oil drum, we need to remove the water and sand and purify the area. It's not ideal for processing, but it's a method to get the oil. And processing takes more and more time, and it'll be harder. And the bottom line is we need to think about the cost to get the crude oil as we're doing the process, because it takes longer and it takes more time and energy. Now we're going to talk about other fuels that are made from fossil fuels, mainly crude oil. Now crude oil also produces gasoline, diesel, jet fuel, heating oil, and polymers. And refiners take the crude oil, and sub-fuels in the crude oil have different boiling points. So if you're knowing boiling point of a particular subfuel that you want, you can heat up crude oil, which will make the subfuel into a vapor form. So for example, if we use this method for gasoline, it'll get piped out as a pure gasoline. And refiners take advantage of the different boiling points of the fuels to get the specific subfuel that we want to vapor form. Now we're going to talk about cogeneration, and it occurs when a fuel source is being used to generate both useful heat and electricity. So we get a natural gas, and it's going to power the engine, and the engine's going to turn a generator and a turbine to produce electricity, and the electricity can be used in a community somewhere. Now because the engine is heating, we can use cold water and put it in the engine, and the heat in the engine can be bathed with cold water to keep it cool. Now because obviously the engine is heating up, the water can be heated up and the cold water becomes hot, and it can be pumped out and can be used in another type of system. So the hot water can be used in a heating system, and it can be used in housing and many different ways that we use the hot water, because the hot water can be used in many types of systems. This is everything that we need to know for 6.3. This is another AP3 video. Thank you for watching.